Okay, Dr. Pitcher here, and in this lecture in Chapter 4, we'll take a look at axial and equatorial positions in cyclohexane. So let's go ahead and draw a cyclohexane in the chair conformation. There we go. That's not too bad. And then I'm going to also draw the other chair conformation. It's not so good here. There we go. And let me go ahead and number these carbons here. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. All right. So now let's go ahead and add in some atoms. So I'm going to go ahead and put some chlorines in the axial positions. Now to draw the axial positions, what you do is you look for where the corner is on your chair conformation and see which way it's pointing. So this corner is pointing up. It's pointing at an angle, but you want to draw the bond straight up. This corner is pointing down, so we will draw the bond straight down. Same as there, and same as there. So our chlorines are all axial. And then to draw our equatorial positions, we draw out and in the opposite direction of where the axial is. So I want to go out and kind of down, like that. So I'll put a hydrogen there, out and kind of up. Out and kind of down. That's a little tricky to draw. Out and kind of up. Out and kind of down. Out and kind of up. So these guys kind of pinched in the middle here are a little trickier to draw. So here the H's are all equatorial. What does this look like in a model? Well, I built this model in the modeling lab to show you guys. Here it is. Okay, let me spin this around here. There we go. So I have chlorines pointing up on carbons 1, 3, and 5. Chlorines pointing down on carbons 2, 4, and 6. And then my equatorial hydrogens. So this is another skill that you want to master, is drawing the axial and equatorial positions on the on a chair conformation. And it's important to do these accurately. It's important to make your chairs accurate, and important to make to draw your axial and equatorial bonds accurately. If you don't, then I don't know that you understand really what axial and equatorial are. So definitely practice this. Now let's do the ring flip. I'm going to take carbon 1 and pull it down, and take carbon 2 and pull it up. Now what just happened? All of my chlorines are now equatorial, and all of my hydrogens are now axial. So when we do the ring flip, the equatorial and axial positions switch. We haven't broken any bonds. We haven't moved any atoms around. We've simply done a conformational change. So we went from all axial chlorines to all equatorial chlorines. So let's see what that looks like on the diagram here, on our drawing here. We've got this chlorine is on carbon 1, is pointing straight up. Well, now it's going to be kind of up. And then our hydrogen that was pointing kind of down is now pointing straight down. On carbon 2, our hydrogen that was pointing kind of up will now be straight up. Our chlorine that was pointing straight down will now be kind of down. And then carbon 3, we've got our hydrogen is now axial, and chlorine's equatorial. Carbon 4, hydrogen is now axial straight up, chlorine equatorial kind of down. Carbon 5, we now have our hydrogen pointing straight down, and our chlorine is kind of up. Again, some of these are tricky to draw. And then carbon 6, our hydrogen is straight up and our chlorine is kind of down. So now our chlorines are all equatorial and our hydrogens are all axial. So it's important to understand that when you do the ring flip, you're going to switch whether things are axial or equatorial. Now, notice that we're not switching what is cis and trans. So give me just one sec here and a few atoms here. I'm going to replace some of these chlorines with hydrogens, and we'll take a look at a few cases. And you did this actually in the lab. So let's go ahead and take a look then at 1,2-di-equatorial. So I'm actually going to call this cis slash trans versus axial slash equatorial. So I'm going to go ahead and let's do this. So I've got my hold on, let's start diaxial here. So I'll draw this guy. And so I have a chlorine axial and a chlorine axial, hydrogen equatorial, hydrogen equatorial. I'm not going to draw in the other ones right now. So this is trans 1,2-dichloro cyclohexane. You can tell clearly these are trans. These guys are trans. They're on opposite sides of the ring. If I look at the average plane of this ring here, yes, they're on opposite sides. If I went to my, tried to make it planar, we can still see, yeah, those guys are on opposite sides. And then if I go to my other conformation here, now they're di-equatorial, but they're still on opposite sides. One's pointing kind of up and one's pointing kind of down. So this is the diaxial. So again, this was carbon 1, so now I've got chlorine there, hydrogen pointing straight down. Here I've got hydrogen pointing up and chlorine pointing kind of down. So this is di-equatorial. But it is still trans. So my point is that cis and trans don't change whether you're diaxial or di-equatorial. Okay, whatever positions you're in, cis and trans won't change. So these are trans, they're still trans. Now if I made the cis, I've got one axial and one equatorial. And if I do the ring flip, I go one equatorial and one axial. But they're still cis. They're both pointing basically the same on the same side of the ring. Okay, we've got up and kind of up. Now, this is going to be different than, let's say, 1,3, where now our diaxial 1,3 dichlorocyclohexane is actually the cis isomer. So cis 1,3 dichlorocyclohexane is diaxial, and cis can also be di-equatorial here. So the take-home message is the following. When doing a ring flip from one chair conformation to the other, only axial and equatorial change. Cis and trans do not change. Oh, sorry, let me put that back in the field of view here. So just to summarize then, let me get that out of the way. There we go. When, or just to reiterate, when doing a ring flip, that's what I call it when you go from one chair to the other is our flip, our ring flip. We're not actually flipping the ring over, but we're doing a conformational change. When doing this ring flip from one chair conformation to the other, only the axial and equatorial change. Cis and trans do not change. So that's important to remember. And in subsequent lecture videos, we'll go ahead and take a look at energies associated with things being in axial positions versus equatorial positions. And we'll look at monosubstituted and disubstituted and multi-substituted cyclohexanes. All right, until next time, stay safe. Bye now.